Let us discuss this example. The space between two square flat parallel plates is filled with oil. Each side of the plate is 720 meter square, which is millimeter. The thickness of the oil film is 15 millimeter. Then the upper plate, which move at 3 meter per second, require a force of 120 Newton to maintain the speed. Determine the dynamic viscosity of the oil, the kinematic viscosity of oil if the specific gravity of oil is 0.95. So we have to calculate the dynamic viscosity, which is the mu. So here we are being given that we have what? The space between two square flats parallel plates is filled with oil. Each side of the plate, if you have a square related like this, that is, each side of this plate is what? Is filled with oil. Each side of the plate is what? 720 meter per second. That is, this side and this side is what? 720 millimeter, which is what? 720. This one is 720 and this one is what? 720. So we have each side of the plate 720 millimeter. So that is, one side is 720, the other side is what? 720 millimeter. So we have to convert it to meter so that we have our area will be meter and meter. Remember that if you convert to meter and meter, we are going to have what? Meter square. So I'm going to have 720 all over what? Millimeter all over what? 1000. So I'm going to have 0.72. 720 divided by 1000. I'm going to have 0.72. 0.72. This one is meter, this one will cancel meter. So each side of the plate is 0.72. The thickness of the oil is filled with 15 meter. Thickness of the oil 115 millimeter. Remember, our thickness of the oil is our what? Our du. So it means our thickness of the oil is what? Du. So we have to convert meter square to what? Meter. So we are going to have 15 divided by 1000. 15 millimeter all by what? 1000 meter. So this will cancel. We are going to have 15 divided by 1000. We are going to have 0.015. 0.015 meter. So with which the upper plate which move at 3 meter per second, that is our velocity, which is our what? Our du. Our velocity is what? Du, which moves what? Which moves with what? Velocity moves what? Velocity. Our velocity is what? 3 meter per second, which is what? Our velocity is what? Du. Why this is our what is what? Dy. So we have a force. A force is required. A force is required, which is what? 120 Newton. A force is 120 Newton. To maintain the speed, determine the dynamic. So we only have a force. Remember, for us to calculate our shear stress, we have what? Force all over what? All over area. So that we can get what? Where we can get our value for shear stress. So what's our force here? Our force here is what? 120 Newton. We are going to have 120 all over what? Our area. Each side of the plate having what? An area of what? 0.72. So two area, that is 0.72 meter times 0.72 meter. So if we multiply 0.72 times 0.72, we are going to have 0.5184. So we are going to have our top will now be 120, our shearing stress 0.5184. If you divide 120 divided by 120 divided by 0.55184, we have 231.5. Approximately 231.5. Remember, our force is measured in what? Newton. Our area is measured in what? Meter square. So since we have gotten our shearing stress, so we now apply our formula as mu is equal to tau is equal to du all over what? Dy. So we have to calculate the dynamic viscosity of this. So what's our shearing stress, which is our tau, is 231.5 is equal to mu. What's our du? Our du is the change of velocity, which is what? 3 meters per second. So our dy is what? Our of distance. This is our dy, this is our dy, and this is our du. This is our du, velocity, this is our dy. So our dy is 0.015. 0.015. So we want to what? We want to calculate for mu. Our mu is 3 all over 0.015. So we can cross multiply. This one will go for this. We are going to have 231.5 times 0.015 is equal to 3 mu. If you multiply 231 times 0.015, I'm going to have 3.4725 is equal to 3 mu. So I want to get what? I want to get my viscosity. I have to divide both sides by 3. So I'm going to have this 3.4725 all over 3. If I divide this one by 3, I'm going to have mu as what? 1.1575. So the dynamic viscosity of the oil is 1.1575 Newton seconds per meter cube, Newton seconds per meter square. Since I've calculated my what? The dynamic viscosity of the oil. So I have to go and calculate the kinematic viscosity of oil. If the specific gravity of oil is 0.95. When I'm talking about kinematic viscosity is the ratio between viscosity and what? Density of the oil. So in my kinematic viscosity, I have V is denoted by V as what? The dynamic viscosity, which is the mu all over what? The rho. So this is the formula to calculate the kinematic viscosity. That is the viscosity itself all over what? Density of the oil. So for me to calculate this, I have to find my density first. Remember that we have been given our density as what? The specific gravity is what? 0.95. According to specific gravity formula, we have specific gravity is what? Density of a liquid all over what? Density of what? Water. So my specific gravity, I've been given specific gravity as what? 0.95. 0.95 is equal to my specific, this is my density liquid all over what? Water. And remember, our water is always 1000 kg per meter cube. So if I cross multiply, I'm going to have 0.95 times 1000 all over what? Which is what? Density of the liquid. So I'm going to have my liquid is what? 0.95 times 1000 is 950. So I'm going to have 950 is equal to what? Liquid. So the density of the oil is what? 950. Since I've gotten my density of the oil, I can easily apply my formula. I'm going to have my V, kinematic viscosity, all over what? The mu. So my mu is what? Dynamic what? Viscosity, which is what? Which is 1.1575. 1.1575 all over what? My density. My density is what? 950. Remember, my density is what? 950 kilogram per meter cube. So my V is what? 1.1575 divided by what? 950. If I divide 1.1575 divided by 950, so I'm going to have my dynamic viscosity is 0.001218 or 1.2184 times 10 to the power minus 3. 0.00128 or 1.218 times 10 to the power minus 3 meter square per second. So the kinematic viscosity is 0.001218 meter square per second. So this is the what? This is the solution of the problem given above. We have considered our dynamic of viscosity as 1.1575 Newton seconds per cube, and we have considered our kinematic viscosity as 0.0001 to 18 meter per second.